Hello students, welcome to this channel on ME Solutions. So today we will solve problem number 2 that has come in GATE 2020 examination. A hollow spherical ball of radius 20 cm floats in still water with half of its volume submerged, taking the density of the water as 1000 kg per meter cube and the acceleration due to gravity as 10 meter per second square. Find the natural frequency of the small oscillations of the ball normal to the water surface in radians per second. So let's quickly solve this problem. So in this problem it is given that there is a spherical ball that is half submerged in the water, and we need to find that what is the natural frequency of the ball if it is given a very small displacement. So first of all, what we'll do, we'll calculate the mass of the ball. So the mass of the ball will be exactly equal to the mass of the water displaced by the ball. So if I represent the mass of the ball by m, so I can write that m is equal to density of the water, that is rho w, multiplied by half of the volume of the ball. M equals rho w to half. So we consider that the radius of this ball is r, so you can say that the volume of ball will be 4 by 3 pi r cube. So if we put the values of rho w, that is 1000 kg per meter cube, the radius of the ball is given in 20 centimeters, so we'll convert it. So we can write 20 centimeters as 0.2 meters. So if we solve this, we'll get the mass of the ball as nearly about 16.75 kgs. So we calculated that the mass of the ball is 16.75 kgs. So now what we'll try to do, let us assume that I'm giving a small displacement of x to this ball. So when I'm giving a small displacement of x to this ball, so what will happen, that the ball will try to displace more fluid, and in return there will be a buoyancy force or a buoyant force that will try to push the ball outwards in an opposite direction of the application of the displacement. So we can write now that, so if I say that x is the displacement that I have given, so then what will be the velocity? It will be x dot, and what will be the acceleration of the ball? It will be x double dot. So let's find out what is the inertia of the ball first. It will be simply mass of the ball multiplied by acceleration, that is 16.75 multiplied by x double dot. Now we'll calculate that what is the buoyant force that is acting on the ball. So every time you remember that whenever there is a body that is submerged in the water or in any fluid, the buoyant force will always be equal to the volume of sorry the buoyant force will always be equal to the weight of volume displaced. So now let's calculate the buoyant force. It will be equal to the weight of water displaced. Or I can write let us say that the weight of the water displaced is W. So W will be equal to volume of water displaced multiplied by the density of water into the acceleration due to gravity. Now here we need to find out that what is the volume of water displaced. So let us go back to the diagram. So I am giving a x displacement in this direction. So what will happen to this ball? It will try to relocate itself in this way. So suppose we are having a top view of this ball. If we see the top view from the top, what it will look like? It will look like a disc of radius r. So when I am giving it a displacement of x, so the volume the water displaced will be equivalent to a cylinder of having radius r and height x. So I can write that weight is equal to volume the water displaced, that is pi r square x multiplied by density of water into acceleration due to gravity. So we can put the values now. For pi 3.14, r we know it is 0.20 meters. It is given to us, the radius of the ball, multiplied by x. The density of water is 1000 kg per meter cube, and the acceleration due to gravity we can take as 10. So now what we will do, we will just equate the inertia of the ball with the weight or the buoyancy force or the weight of the water displaced. So we'll get 16.75 multiplied by x double dot will be equal to 3.14 multiplied by 0.20 whole square x 1000 into 10. Now if we simplify this, we'll get around 16.75 x double dot will be equal to so we can directly write Yeah, one thing I've forgot to mention here that so when I'm applying a small displacement in this direction, so the buoyancy force will be in upwards direction. So I can write that they are actually not equal. The inertia force is minus times the buoyancy force because they are acting in opposite direction. So in order to equate them, we need to put a negative sign. Or we can say that the sum of the forces is zero because the ball is in equilibrium. So now if we write this equation again, that will be equal to 0, and we'll rearrange the terms. Now if we compare it with the standard equation of the vibration of a spring mass system, we can directly write omega square is equal to 1256.63 upon 16.75. Now if we simplify it, we'll get omega around 8.66 radians per second, which is a natural frequency of the system given to us. So let's review the problem again. We have been given a hollow spherical ball of radius 20 centimeter that was floating in the still water with half of its volume submerged. And we were given the density of water as 1000 kg per meter cube, the acceleration due to gravity as 10 meter per second square. We have to calculate the natural frequency. So what we did, we initially found the mass of the ball by equating the mass of the ball with the mass of the water displaced. So since it is already given that the ball is half immersed in the water, so we can write that the mass of the ball is density of the water into half of the volume of the ball. So from this we got the mass of the ball, and then we gave a displacement of x to the ball, and the ball started to exhibit a buoyant force in a direction opposite to the application of the displacement. Then we calculated the buoyant force, which is equal to the weight of the water displaced. Then we calculated the volume of the water displaced. Then we equated the inertia force acting on the ball with the buoyancy force. So since they are in opposite directions, so we have taken the minus sign here. So in the end we got the value of frequency as 8.66 radians per second. So thank you very much for watching this video. I hope you like this video. Kindly let me know your views in the comment section, and please subscribe to my channel.